Okay. So control system, these are the topics. Note down. What is first one? Basics and stability analysis. And second one, root locus stability analysis. And third one, time response analysis. So time response divided into two regions. One is transient region. So transient response analysis. Another one is steady state region. So we have to discuss about steady state response analysis. Okay. Then fourth one, frequency response analysis. So according to the GATE syllabus, we have to study polar plot and Nyquist plot and Bode plot and gain margin, phase margin. Gain margin, phase margins are used in relative stability analysis. What is the relative stability means? To compare the stability of two different systems, we are using relative stability analysis concept. Then fifth topic, controllers, compensators. Okay, in controller we have a proportional controller, integral controller, derivative controller, and a PI controller, and a PD controller, PID controller. All the controller we have to discuss. And in compensator we have four types. Majorly we have lead compensator, lag compensator, lead lag compensator, lag lead compensator. So that the things will be covered under compensator. The next one, state variable analysis. So state variables are belongs to initial condition of a circuit. For capacitor, which one is initial condition? Initial voltage across a capacitor. For inductor, current, initial current. Okay. The next one, signal flow graph and block diagram reduction technique. So this is the syllabus. So for GATE exam, we have 7 to 10 marks weightage. In GATE exam, 7 to 10 marks. For GATE exam, 7 to 10 marks. And for engineering service exam, we have around in preliminary, so around 25 marks. So in ESC engineering service exam, in preliminary, around 25 marks. Then for TNEB or TRB also, we can expect around 10 marks. And this is one of the very easiest paper compared to any other technical paper. So by comparing all the technical paper, the easiest one paper is control system. Yes, we can start first topic, take basics and stability analysis. Take first topic. First topic, basics and stability analysis. Yes, first write down the list of topic, take first one. First one we will discuss what is system. Take first topic, system. And second topic, we will study about control system. Second topic, control system. Third one, block diagram of control system. Third one, block diagram of control system. Fourth one, we have open loop system. Open loop system. And fifth one, closed loop system. Fourth one, open loop system. And fifth one, closed loop system. So what is the main difference between open loop system and closed loop system?
Feedback.
Yes, feedback is present in closed loop system, but there is no feedback in the open loop system. Okay. Next, sixth one, open loop transfer function. Seventh one, closed loop transfer function. Sixth one, open loop transfer function. Seventh one, closed loop transfer function. Then eighth one, take eighth one, transfer function of various RLC circuit. Eighth one, transfer function of various RLC circuit. Transfer function of various RLC circuit. Then ninth one, analysis of RLC circuit. Analysis of RLC circuit. Analysis of RLC circuit. Then 10th one, stability in terms of response curve. Response or output both are same. Stability in terms of response curve. Then 11th one, stability in terms of location of poles. Stability in terms of location of pole. Stability in terms of location of pole. 12th one, stability in terms of time constant. Stability of a system in terms of time constant. Stability in terms of time constant. Stability in terms of time constant. Then 13, stability of first, second, third order system. Stability of first, second, third order system. Stability of first, second, third order system. Do you know what do you mean by order of system?
Number of energy storage elements present in the circuit is
Yes,
equal to
number of energy storing elements, or in terms of transfer function we can say number of poles. So number of poles called as a order of system. So if a system have only one pole, that is called as a first order system. If a system have two poles, that is called as a second order system. If a system have three poles, that is called as a third order system. Or next 14th, take 14th. Stability of higher order system in terms of root Harvin's criteria. Stability of higher order system in terms of Ruth Harvitz criteria. Yes, these are the topics for first one. So first we will study what is the definition of system and definition of control system and a block diagram of control system. So in control system we have open loop system and closed loop system. In closed loop system we have two types. What are the two types of closed loop system? Positive feedback system and negative feedback system. Then we will derive open loop transfer function, closed loop transfer function. Okay. So these are the basic. Then first here, this is also important topic. Transfer function of various RLC circuit and analysis of various RLC circuit. The next stability concept. So stability in terms of response curve, stability in terms of location of poles, and stability in terms of time constant. And the stability of first, second, third order system. But suppose if it is fourth order, fifth order, then we have to use Root Harvitz criteria to check the stability. So these are the topics. Let's go through the topic. Yes, go through the topics, then we will discuss one by one. Yes, first we will study about system. So can you give any example for system? Student, first of all, we'll start what is system. First of all, can you give any example for system? Example. Student, can you give any example for system?
There when number of components or elements are connected in a sequence to perform a specific function, sir.
I asked example. Your definition is correct. Can you say any example? Systematic example therilla. What is any one of the example?
Fan, sir.
Yes, electric fan is a system. Human body also a system. Classroom also. The classroom also system. So now you said no, electric fan also system. So electric fan la, what are the components are present? In electric fan, ceiling fan, what are the components are present? So we have motor, then capacitor, okay, some wires, wiring connection.
Condenser.
Okay, so these are the etc. So these are the components: motor, blade, capacitor, some wires, and etc. So these are the components connected in a specific manner in order to generate the proper output. So we have to get the proper output. Which one is input? Electricity. Electricity is the input. Which one is output? Yes, electrical energy converted into mechanical energy. So that due to that mechanical energy, that blades are rotating. So we will get the circulation of air. That is the output. So listen, these physical elements are connected in a specific manner in order to generate the proper output. So take system definition. Elements. Elements are blocks. Elements or blocks are connected in. Elements or blocks are connected in a specific manner. Elements or blocks are blocks are connected in a specific manner in order to generate desired output. Sorry, proper output. In order to generate proper output. In order to generate proper output. So what is the definition of system? Elements. For electric fan, we can say these are the elements. Suppose if you take any industrial system. So in industrial system, what are the things are connected? Blocks are connected together. Have you got my point? So electric fan is a small system. So here these are the elements connected in a specific manner. Suppose if you say any industrial system, so that time what we can say? Various blocks are connected in a specific manner. That's why I gave that term. So what is the definition of system? Elements or blocks are connected in a specific manner in order to generate proper output. Okay, take example, electric fan. Example, electric fan. Electric fan. So electric fan is one of the best example for system. In electric fan, these are the components. What are the components? Motor, blades, capacitor, wires, etc. So these components are connected in a specific manner to get the proper output. Okay. So for electric fan, which one is input? Power supply. Which one is output? Air circulation. Okay. Air circulation is the output. Okay. That is system. Now take second one. Control system. Control system. Yes, what is the definition of control system? Yes, system is controlled or directed or regulated by internally or externally to get the desired output. Now write the definition. Or listen. சப்போஸ் நம்ம வீட்ல எலக்ட்ரிக் ஃபேன் மட்டும் இருக்கு, அதுக்கு ரெகுலேட்டரே கிடையாது, அப்ப ஃபேன் அவுட்புட் கிடைக்குமா கிடைக்காதா? ஸ்டூடெண்ட், will you get the output or not?
Yes, sir.
எலக்ட்ரிக் ஃபேன் மட்டும் இருக்கு, ரெகுலேட்டர் இல்லைனாலும் we will get the proper output. ஏர் சர்க்குலேஷன் ப்ராப்பர் அவுட்புட் வரும். பட் சம்மர் டைம்ல நம்ம ஃபேன் எப்படி வைப்போம்? ஃபுல் ஸ்பீட்ல வைப்போம். இதே வின்டர் டைம்ல ஃபேன் எப்படி வைப்போம்? லோ ஸ்பீட்ல வைப்போம். அதுதான் வந்து டிசைட் அவுட்புட். நம்மளுக்கு தேவையான அவுட்புட் டிசைட் அவுட்புட் மேபி ஹை ஸ்பீடு ஆர் மேபி லோ ஸ்பீடு. அப்ப இந்த ஹை ஸ்பீடோ லோ ஸ்பீடோ அச்சீவ் பண்றதுக்கு which one is used? Regulator. That regulator with electric fan is called as a control system. Electric fan with regulator is called as a control system. In that, which one is controller? Regulator is a controller which is used to get the desired output. So take definition of control system. System can be controlled. System can be controlled. System can be controlled or directed. System can be controlled or directed or regulated. System can be controlled or directed or regulated by internally or externally. By internally or externally. Internally or externally to get desired output. To get desired output. To get desired output. Instructed. So this is definition of control system. What is the definition? System can be controlled by or directed or regulated by internally or externally in order to get desired output. So take example. Take same example. Electric fan with regulator. Electric fan with regulator. Electric fan with regulator. So this is one of the basic definition of control system. I repeat again. So system can be controlled or directed or regulated by internally or externally to produce the desired output. So best simple example, electric fan with a regulator. So without regulator, electric fan alone is called as a system that will give the proper output. But to get high speed or low speed, which one is used? Regulator is used, that is nothing but controller. So here regulator is a controller. That's why electric fan with regulator is the example for control system. Electric fan is the example for system. Okay. Now take block diagram of control system. Take controller. This is plant or process. Then output. Output also called, this is response. Response or output. So here we have an input or called as a excitation. So not visible, I will use. So here we are applying. Now it's okay now. Yes, now here we are applying input or called as a excitation. So this is one of the simple block diagram of a control system. So here input applied, input also called as excitation. So here controller, this is system called as a plant or process. So we'll get the output. That output also called as a response. Here the system gets affected by noise. So system gets affected by noise or disturbance. System gets affected by noise or disturbance. So suppose if you take an amplifier. So in amplifier, what are the components are there? In amplifier, what are the components are there? Transistor. Okay, if amplifier designed in using transistor, then we have a transistor component, some important capacitance, coupling capacitance, some capacitance, resistance. So everything connected in a decided manner to get the amplified output. Okay. So that amplifier we can say as a plant or process. So for that amplifier, which one is the controller? Which one is controller? For amplifier, which one is input? For amplifier, which one is input? Amplifier, which one is input? Mic. So நாம் பேசுறோம்ல அதுதான் என்னது input. So that mic converts the physical quantity into electrical quantity. That electrical signal applied to the amplifier. So அப்ப நம்ம பேசுற voice தான் input. So mic is the input. Which one is output? Which one is output? Speaker. So from the speaker we will get the amplified output. So for amplifier, elements are connected in a physical manner, and input when the mic, output is a speaker. So that is amplifier. So how will you get a more high sound or low sound? Which one is used with tuning, with a tuner. So amplifier with a tuner is example for control system. So even without tuner also we'll get the output, amplified output, but that is fixed output, proper output. Will you get desired output? No. So same as electric fan with the regulator. In electric fan, even without regulator, we will get the output. That is fixed output, not a desired output. To get the desired output with electric fan, we have to connect to the regulator to get the desired output. Similarly, amplifier is a system to get the proper output. But in order to get the desired output, we have to connect to the tuner. The tuner will act as a controller. I got my point. So this and all theory only. So input or excitation applied. This controller is the main portion of control system. So which is used to control the noise or disturbance. The next here, plant or process. Okay, plant or process which is gets affected by noise or disturbance. Due to that, we won't get the desired output. To get the desired output, controllers are connected with the system. I got my point or not? Assume this is amplifier. In amplifier, we will get output. Sometime noise affected means will you get the desired output? Will you get desired output? No.
No,
So due to this noise or disturbance, we won't get the desired output. Therefore, these controllers are used to reduce the noise. So we will get the desired output. I got my point or not? So what is the main purpose of controllers? Understand here. To reduce the noise. That is main purpose. So assume amplifier. So amplifier will give the output. Amplifier will give some output. But if the amplifier gets affected by noise or disturbance, will you get desired output? No. Due to this noise, amplifier will not give the desired output. To overcome that, controllers are used. So controllers are used to reduce the noise. So we will get the desired output. So in amplifier concept, we have two types of noise. What are the two types of noise? Internal noise and external noise. So we have internal noise and external noise. So what do you mean by internal noise or what do you mean by external noise? So what do you mean by internal noise or what do you mean by external noise? So in the amplifier circuits itself, noise comes due to some elements or short circuit or either or element fault or element defect. Due to that, the noise occurs. That is called as a internal noise. So what is external noise? What is external noise? எஸ் இப்போ ஒரு கிளாஸ் எடுத்துட்டு இருக்கோம்னா நீங்க வெளியிருந்து ஒரு 10 பேர் உள்ள பேசிட்டே இருந்தாங்கன்னா அதுதான் என்னது எக்ஸ்டர்னல் நாய்ஸ். ஸோ எக்ஸ்டர்னல் நாய்ஸ் நாட் அசோசியேட்டட் வித் சிஸ்டம், ஒன்லி இன்டர்னல் நாய்ஸ் associated with the system. Anyway, it may be an internal noise or maybe external noise that will affect the output of the system. Will affect or not? So amplifier குள்ள ஏதாச்சும் ஒரு elements defect இருந்தாலும் we won't get the desired output. அதே மாதிரி நம்ம எல்லாம் பேசிக்கிட்டே கிளாஸ்ல ஒரு 10 பேர் இருக்காங்க, ஒரு 5 மெம்பர்ஸ் பேசிக்கிட்டே இருந்தாலும் அவுட்புட் என்னவா இருக்காது, we won't get the desired output. So to get the desired output, which one is used? Controllers are used to get the desired output. That controller is nothing but tuner here. So note on this. So no need to discuss in much detail. If you need a detailed explanation, go through the textbook, but only the basic important thing for understanding purpose and also in the gate exam point of view. So I repeat again. So this is a block diagram of control system. So there are 5 elements are there. First one is input or excitation. Then this is what? Output or response. Then third one controller, and fourth one plant or process is called as a system. And here fifth one noise or disturbance. So you assume that amplifier is a system. Amplifier with a tuner is a control system. Why means the amplifier gets affected by internal noise or maybe external noise. To overcome that, which one is used? Controllers are used to get the desired output. Already I told. So system used to get the proper output, but controllers are used to get the desired output. Okay, controllers are used to get the desired output. Students, have we completed?
Yes, sir.
Yes. Yes, classification of control system. Take. We have open loop system and closed loop system. Open loop system and closed loop system. So control system is classified into 2 categories. First one open loop system, second one closed loop system. So is this block diagram? This block diagram belongs to open loop system or closed loop system?
Open loop.
Yes. Why? There is no feedback. So this block diagram belongs to open loop system. So now what is the definition of open loop system? Output depends on input. For any system arunda output kandipa eppadi irukanum, depends on input. Appa input 0 ah irundha output enava irukanum, 0 ah irukanum. Adu or system oda important point. So for any system output depends on input, but here controller is independent of output. For definition of open loop system, take output depends on input, output depends on input, output depends on input, but controller is independent of output or output changes. Controller is independent of output or output changes. Controller is independent of output or output changes. I repeat again. So what is the definition of open loop system? Output depends on input, but controller is independent of output or output changes. Okay. So what is the main advantage of open loop system? First one, easy design or construction. So this is main advantage of open loop system. Easiest design, easiest and simple design. Easiest and simple design. So if a design is simple, what about cost? Less cost. Okay. So simple design, simple construction, so less cost. Third one, what about the maintenance? Is it open loop system need more maintenance or less maintenance? Less maintenance. less maintenance. And what about stability? More stability or less stability?
More stability.
High stability. Open loop system always stable in nature, so stability is more. And what about gain? Gain also more. So these are the some important advantage of open loop system. So these are the important advantages of open loop system. Easiest and simple design, so less cost and less maintenance and troubleshooting. And open loop systems are stable always in nature, and gain of the system is high. Gain of the open loop system is high than closed loop system. Because of no. So like what is the transfer function of closed loop transfer function formula? G of s divided by 1 plus G of s h of s. So G is the gain of open loop system. So for this is closed loop transfer function. How will you write open loop transfer function? Open loop transfer function equal to G of s. So open loop transfer function G, but closed loop transfer function is G divided by 1 plus G h. So which one is have more gain? Open loop system or closed loop system?
Open loop system.
Yes, because of closed loop system, the gain decreases by the factor of 1 plus GH. So open loop system has more gain. So these are the advantages of open loop system. Students, tell me what is first advantage?
Easier design, sir.
Yes, easier and a simple design. Second,
Low
low cost. Third one,
less maintenance.
less maintenance and troubleshooting needed. And fourth one, stability is more and also gain also more. But what about drawback? What is the main drawback?
Accuracy.
Accuracy is less. So less accuracy. And what about stability, sensitivity? About sensitivity, we will discuss more sensitivity or less sensitivity. More sensitivity. Open loop systems are sensitivity. These two all are the major drawback of open loop system. Less accuracy and more sensitivity. Less accuracy and more sensitivity. So what about sensitivity of human? Is it human should have more sensitivity or less sensitivity? More sensitivity, yeah. அப்படி more sensitivity னா உங்க வீட்ல சொல்லுவாங்க ஏதோ சொல்லிட்டாவே போதும் மூக்கு மேல கோவம் வருதுன்னு சொல்லுவாங்க. அதுக்கு பேர் தானே more sensitivity. ஆமா தானே? ஆமாவே இல்லையா? ஸ்டூடெண்ட் அப்ப சென்சிட்டிவிட்டி மோர் அதிகமா இருக்கணுமா கம்மியா இருக்கணுமா? அதிகமா இருக்கணுமா? சோ கம்மியா இருந்தா என்ன ஆகும்? கம்மியா இருந்தா சொரண கெட்டவன் சொல்லுவாங்களாமா. சென்சிட்டிவிட்டி அதிகமா இருந்தா மூக்கு மேல கோவம் வருதும்பாங்க. சென்சிட்டிவிட்டி கம்மியா இருந்தா சொரணையே இல்லையா உனக்கு சூடு சொரண வெக்கம் மானம் ரோசம் எதுவுமே இல்லையான்னு கேட்பாங்க. ஸோ தயவு செய்து அட்டண்டன்ஸ் போடுங்க கிளாஸ் எடுக்கிறப்ப. நேத்தெல்லாம் பாருங்க யாருமே அட்டண்டன்ஸ் போடவே இல்லை. அப்ப நான் உங்களை அப்படிதான் கேட்கணும், சூடு இல்லையா சொரணம் இல்லையான்னு தான் கேட்கணும். ஒரு நீங்க லிங்கை கிளிக் பண்றீங்க, அதுல போய் ஜாயின் பண்றீங்க, அந்த டைம்குள்ள உங்க நேம் டிபார்ட்மெண்ட் போட்டு ஒரு அட்டண்டன்ஸ் கொடுக்கறதுனால என்ன கஷ்டம்? அதனால தயவு செய்து அட்டண்டன்ஸ் போடுங்க. அப்ப என்னன்னா அது இப்ப நான் வந்து இன்னைக்கு என்னுடைய கிளாஸ்ன்னு சொல்லியிருக்கேன், எல்லாமே அட்டண்டன்ஸ் போடுறீங்க. நேத்து ஒரு சார் கிளாஸ் எடுக்கிறார் அட்டண்டன்ஸே போடல, அப்ப அந்த சாரை நீங்க மதிக்கல, ஒரு குருவுக்கு பண்ண துரோகம். அதனாலே உங்களுக்கு ஒரு மார்க் கம்மியாயிரும். ஆமாங்க. ஸோ அந்த காலத்துல குருகுல கல்வி முறை கேள்விப்பட்டிருக்கிறீங்களா? நீங்க சீடரா போய் ஒரு குருகிட்ட சேர்றப்ப என்னென்ன சீடருக்கு எல்லா ஒர்க்கும் நீங்க தான் பார்க்கணும். சரி, குருவுக்கு எல்லா ஒர்க்கும் நீங்க தான் பார்க்கணும். குருவுக்கு, குருவோட ஒய்ஃபுக்கு, குருவோட பையன் பொண்ணுக்கு எல்லாத்துக்குமே என்ன நீங்க தானே பண்ணணும், பணிவிட செய்யணும். நீங்க ராஜ பரம்பரையா இருந்தாலும் அங்க குருவுக்கு போய் பணிவிடை செஞ்சுதான் ஆகணும். அது குருகுல கல்வி முறைன்னு சொல்லுவாங்க. ஸோ நீங்க அதனால அட்டண்டன்ஸ் கண்டிப்பா போட்டுருங்க. பாருங்க எனக்கு இன்னைக்கு அட்டண்டன்ஸ் நிறைய பேர் போட்டிருக்கிறீங்க. நேற்று கிளாஸ் எடுக்கிறப்ப பார்த்தா அட்டண்டன்ஸ் யாருமே போடவே இல்லை. அதெல்லாம் அந்த ஒரு ரெஸ்பெக்ட் இல்லாத திங்ஸ். அதெல்லாம் கிளாஸ்ன்னு சொல்லியாச்சு, லிங்க் அனுப்பியாச்சு, எந்த சார் எடுத்தாலும் நீங்க அட்டண்டன்ஸ் போட்டுட்டு லிங்க்ல ஜாயின் பண்ணிக்கோங்க. ஸோ அட்டண்டன்ஸ் கண்டிப்பா தேவை. ஒரு 75 ஸ்டூடெண்ட்ஸ் இருக்கிறீங்க. ஸோ அதில் ஒரு 10 ஸ்டூடெண்ட்ஸ் அட்டண்டன்ஸே சொல்றதே இல்லை. அவங்களெல்லாம் கண்டினியூஸா பார்க்கலாம், இல்லைன்னா குரூப்ல இருந்து ரிமூவ் பண்ணிடலாம். நீங்க ஆப்சென்டா இருந்தாலும் குரூப்ல இன்ஃபார்ம் பண்ணிடணும்ல கிளாஸ் ஆப்சென்ட். ஓகே. சோ அப்ப நம்ம ஹியூமன் எப்படி இருக்கணும்? சென்சிட்டிவிட்டி கோவப்பட வேண்டிய இடத்துல கோவப்படணும், அமைதியா இருக்க வேண்டிய இடத்துல அமைதியா இருக்கணும். ஸோ அப்படிதான் நம்ம ஹியூமன் லைஃப் போக முடியும். எல்லா இடத்துலையும் கோவப்பட முடியாது, எல்லா இடத்துலையும் அமைதியாகவும் போக முடியாது. ஸோ அதை நீங்க உங்க வாழ்க்கையில் எக்ஸ்பீரியன்ஸ் ஆக கத்துக்குவீங்க. ஸோ ஹியூமன் பொறுத்த அளவுக்கு சென்சிட்டிவிட்டி பேஸ்ட் ஆன் த சுச்சுவேஷன். ஒவ்வொரு சுச்சுவேஷன்ல நம்ம கோவப்பட்டு தான் ஆகணும். ஒவ்வொரு சுச்சுவேஷன்ல நம்ம எப்படி போய் ஆகணும்? இருக்கிற இடம் தெரியாம தான் இருக்கணும். பட் கண்ட்ரோல் சிஸ்டம் எப்படி இருக்கணும்? அதிக சென்சிட்டிவிட்டியோட இருக்கணுமா, கம்மியான சென்சிட்டிவிட்டியோட இருக்கணுமா? கண்ட்ரோல் சிஸ்டம் எப்படி இருக்கணும்? கண்ட்ரோல் சிஸ்டம் மஸ்ட் பி மோர் சென்சிட்டிவ் ஆர் லெஸ் சென்சிட்டிவ். நீங்க எழுதி இருக்கணும்ல, டிஸ்அட்வான்டேஜ். மோர் சென்சிட்டிவிட்டிங்கிறது டிஸ்அட்வான்டேஜ் ஆஃப் அ சிஸ்டம். ஏன்னா சிஸ்டம் சென்சிட்டிவிட்டின்னு இங்க என்ன சொல்லுவாங்கன்னா, ஏதாச்சும் ஒரு பேராமீட்டர்ஸோ, சர்க்யூட் பேராமீட்டர்ஸோ இல்ல சிஸ்டம் பேராமீட்டர்ஸோ இல்ல எக்ஸ்டர்னல் கிளைமேட்டோ ஏதாச்சும் சேஞ்ச் ஆனா கூட அந்த சிஸ்டமோட அவுட்புட் என்ன ஆகக்கூடாது? சேஞ்ச் அஃபெக்ட் ஆகக்கூடாது. ஸோ இப்போ மார்னிங் 10 o'clock இந்த அவுட்புட், மதியம் 12 o'clock வெயில் வந்துருச்சு அதனால வேற அவுட்புட், அப்புறம் சாயந்தரம் வேற அவுட்புட், நைட்டு கூலிங்கா இருக்கிறப்ப வேற அவுட்புட். அந்த மாதிரி கண்ட்ரோல் சிஸ்டம் டிசைன் பண்ணா அது பெஸ்டா இருக்குமா? இருக்காது. ஒரு ஃபுல் டேக்கு அதோட அவுட்புட் எப்படி இருக்கணும்? ப்ராப்பரா தான் இருக்கணும். அப்ப கண்ட்ரோல் சிஸ்டமோட சென்சிட்டிவிட்டி எப்படி இருக்கணும்? லெஸ்ஸா தான் இருக்கணும். So practically control system should have less sensitivity, but the disadvantage of open loop system have more sensitivity. Okay, now take next one, closed loop system. Take next heading, closed loop system. So same as open loop system. So feedback, this is input, so this is block diagram of closed loop system. Take down the block diagram. So input is supplied. Then here we have this is a comparator. The output is error. Then we have a controller. Then this is plant or process. This is response or output. Output or part of output connected back to the input, that is called as a feedback. So in open loop system there is no feedback, but this is closed loop system, compulsory have the feedback. That is the main difference between open loop and closed loop system. So this is block diagram of closed loop system. So what is the extra element present in the closed loop system?
Feedback.
Student, what? Feedback. Okay, what is feedback? Output or part of output connected back to the input. Please write output or part of output. Definition of feedback. Output or part of output. Output or part of output connected back to the input. Output or part of output. Output or part of output connected back to the input. I repeat again, what is feedback? Output or part of output connected back to the input. So we have two types of feedback. What are the two types of feedback? Yes, note down types of feedback. First one, positive feedback. Positive or short we can say positive feedback. Take second one.
Negative.
Yes, negative. Second one, negative. First one, positive feedback. Second one, negative feedback. For control system, which one is best? Positive feedback or negative feedback?
Negative feedback.
Yes, negative feedback have more advantage. But in order to design the amplifier, which one is used? Have you studied a feedback amplifier? That is oscillator. In oscillator design, which one is best? Positive feedback or negative feedback?
Positive.
feedback.
Yes, for oscillator, positive feedback is best. But here in control system, negative feedback is best. So if you have two types of feedback, positive feedback and negative feedback. So here after positive feedback, I will say short form. Positive feedback. How will you write negative feedback? I will write NFB. That is short form. So positive feedback and negative feedback. Positive feedback and negative feedback. So what do you mean by positive feedback? Positive feedback. What do you mean by positive feedback? Input and the feedbacks are in phase. Like input and the feedback values are in phase. Input and feedback value. Input and feedback values are in phase. See, suppose if you say this is input and a feedback value like this. But amplification different may accept, but input output have same phase. Sorry, input and feedback are have same phase or opposite phase. Same phase. Now, assume this is input. This is feedback value. This is input feedback. So this is input. Now this is output. Suppose assume this is like a sine theta. Here sine of theta plus some degree. Okay, theta plus 90 degree. That is something like. Now here input and feedbacks are same phase or out of phase. Student, tell me. So here sine theta, here also sine theta. So input outputs are in phase. But in negative feedback, input and feedback values are out of phase. Like in negative feedback, input and outputs are in out of phase. Sorry, input and feedback values are in out of phase. Output also we can say because of part of output is called as a feedback. So student, tell me what is positive feedback? Input and feedbacks are in phase. What do you mean by negative feedback? Input and feedback values are out of phase. Yes, students, now go through the block diagram. Is it positive feedback system or negative feedback system? Student, tell me the answer. Here minus irukku, ingi minus irukku. Whether positive feedback system or negative feedback system?
Negative feedback, sir.
Positive feedback system. Inga input and feedback. Input li minus, feedback li minus. அப்ப ரெண்டுமே in phase out of phase
In phase.
in phase. இது minus sin theta, இது minus sin theta. அப்ப input and feedbacks are in phase or out of phase? In phase. அப்ப இது positive or negative?
Positive.
Positive.
Positive feedback system. வேணா இங்க இப்படி பாத்துங்க. For understanding purpose, assume A and B. ஏங்கிறது பாயிண்ட் சிம்பிள் பிளஸ் ஆர் மைனஸ் வரும், பி பிளஸ் ஆர் மைனஸ் வரும். ஸோ ஏபி, ஸோ ஏவும் பிளஸ் பியும் பிளஸ், அப்ப என்ன ஃபீட்பேக்? பாசிட்டிவ் ஃபீட்பேக். ஏ பிளஸ் பி மைனஸ், அப்ப என்ன ஃபீட்பேக்? negative feedback. A minus, B minus, up and feedback.
Positive feedback.
Positive feedback. A minus, B plus, up and feedback.
Negative feedback.
Negative feedback. Please note down. If both A and B are same sign, அதுவும் note பண்ணீங்க. If both A and B are same sign. If, write the point. If A and B are same sign, என்ன feedback? Positive feedback system. If A and B are opposite sign, negative feedback system. Please note down. If A and B are same sign, if A and B are same sign, positive feedback system. If A and B are same sign, positive feedback system. If A and B are opposite sign, then negative feedback system. Yes, students, now tell me a quick revision. What is feedback? Closed loop system have the feedback, but there is no feedback in open loop system. So what do you mean by feedback? Output or part of output connected back to the input. What are the two types of feedback? Positive feedback and negative feedback. So input and outputs are in same phase means positive feedback. Input and outputs are in opposite phase means negative feedback. So here you take if A and B are same sign, positive feedback system, plus or minus minus. If A and B are in opposite sign, what type of system? Negative feedback system. A positive, B minus. Upper which feedback system? Negative feedback system. A negative, B plus. Then was negative feedback system. A minus, B minus. What type of feedback? Positive feedback. Supposing A not mentioned. A not mentioned. Now here they mentioned plus. What type of feedback?
Negative
A
feedback.
not mentioned. B value positive. So what type of feedback?
Negative
Here
feedback.
nothing mentioned. So is it default positive or negative? A. Default positive. Appa what type of feedback? Positive feedback system. Suppose if you have minus here, negative feedback system. புக்ல அப்படிதான் இருக்கும். டெக்ஸ்ட் புக்ல இங்க பிளஸ் இருந்துச்சுன்னா அவங்க அப்படிதான் சொல்லிப்பாங்க. Here if you have plus, what type of feedback? Positive feedback. If you have minus, negative feedback. But gate problems la both are plus, then positive feedback. Both are minus, positive feedback. One is plus, another one is minus. Negative feedback system. இங்க எதுவுமே இல்லைன்னா default we can take it as a plus. That understand? Now what are the advantage of closed loop system? Yes, high accuracy because of this feedback comparison error reduced, high accuracy. Second, yes, less sensitive. These are the two main advantage of closed loop system. So error is less, so high accuracy and less sensitivity. High accuracy and less sensitive. Next disadvantage, we can write. So design is simple or complex? Yes, complex design. So automatically to implement this we need more cost. Third, yes, more maintenance needed. Yes, gain of the system stability is more or less? Yes, less stability, less stable, and less gain. So gain is decreases. So in open loop system gain is more, but in open loop system gain is less. So same points only we repeated. So here advantages, here that is all disadvantages. Here open loop system disadvantage means that are all the advantages in closed loop system. Yes, next topic. Block diagram of open loop system in terms of mathematical modeling.